Hello friends, I am George Macon and welcome to JJ's Classroom. In today's lecture, I am going to discuss with you a thin layer chromatography. You are familiar with the name of the technique, that is thin layer chromatography. The technique is similar to the paper chromatography, except that here in TLC, the short form of the technique is the TLC, that is 0.25 mm thin layer of some inert material like aluminum oxide Al2O3, magnesium oxide, silicon dioxide are used as the substrate instead of the paper. Okay, a layer of any one of these oxides which are mentioned earlier are made from a slurry of powder in a suitable inert solvent. Now that slurry is sprayed evenly over a flat surface of a glass and then it is dried. So that's how the thin layer of a particular those oxides are made on a glass surface, and then it is dried out. It becomes TLC plate. It may be sprayed manually or mechanically. Now the advantage of using inert substrate instead of paper is that is more reactive. Developing reagents such as strong acids can be used to react the compounds without destroying the substance. Okay, that means if you want to use developing reagent like strong acids, then if you use paper as a supporting material, then what happens? It may be destroyed. But when you use thin layer TLC plates, okay, those oxides, the layer of oxides are not destroyed with the help of the strong acids. That means you can easily use them as a mobile phase. Now, okay, thin layer chromatography may be used with reagent like H2SO4, as we mentioned earlier, strong acid which react with paper, and especially useful for the separation analysis of high molecular weight biochemical compounds. A wide variety of mixtures such as amino acid, dyes, food coloring, drugs, sugar, natural products, insecticide may be separated and identified. Okay. For microanalytical studies of inorganic ions and salt, for example, mixture of ruthenium, rhodium, palladium, okay, IR and aurum was quantitatively separated by TLC. Those are some use of TLC. The technique of thin layer was first introduced by Ismailov and Schreiber in 1938. Now, the next point of our discussion, that is superiority of TLC over other chromatographic technique. Why chromatographic TLC is more superior than other chromatographic techniques? It is a long question in university examination. Some of the point mentioned here are: it is a simple equipment. Okay, in TLC there was no need of any highly automated instrument. Simple instrument or simple equipment used for the analysis. Short development time. Okay, in TLC the development time is only about 1 hour. 1 hour or so for good separation on inorganic adsorbent layers. Okay, this is an advantage of TLC over paper and column chromatography, which requires several hours or days. Okay, wide choice of stationary phase. The method may be employed for adsorption, partition, like reverse phase or ion exchange chromatography. There was a wide choice of a stationary phase available for the TLC analysis. Early recovery of the separated component. When once the mixture, the component are separated, then you can easily recover those substrate or those component from the TLC plate. It is possible to remove the powdery coating of the plates by scraping with a knife. Next point, that is, once a compound is recovered from the TLC plate, okay, when the components are separated on the TLC plate, and when you are scraping out those materials from the surface of the TLC plate, then they are dissolved in suitable solvent. Okay, then those solutions are quantitatively undergo analysis for like calorimetric and spectrophotometric analysis. With the help of this calorimeter, spectrophotometer, you can measure the intensity of that particular substance that dissolve in the solution. Okay, then separation effect, there was no separation effect on a TLC plate, and because of that reason it is a superior technique compared to all other paper chromatographic technique. Easy visualization of a separated compound. You can easily detect those material which are separated on a TLC plate. Detection of a fluorescence compound under UV light. When you if you put that TLC plate under the UV chamber, those components which are separated are easily visualized on the TLC plate. So that is one kind of a visualization of that component on a TLC plate. Sensitivity. Okay, sensitivity is extremely sharp. Even the usual spray reagent will be able to detect much smaller quantities. Okay, so here it is the range of the sensitivity is given to us, that is 10 to 100 folds as compared as the paper chromatography. It is important as a point of MCQ. Okay, variable thickness of thin layer is also there. The method used in TLC analysis may also be applied for the preparative separation with the aid of thicker layer, as well as to most separation by column chromatography. Chemically inert stationary phase. Here the greatest merit of inert stationary phase is used in TLC lies in affording a vigorous means of detection, including the application of strong heat or of corrosive reagent like concentrated sulfuric acid. So these are some points by which or because of which TLC is more superior than other chromatography technique. Now in experimental techniques, okay, the point number 1 in experimental technique is a coating material. Okay, which kind of coating material are used in on TLC plate? As you know that a large number of coating material are known which are commercially available. Okay, those materials are the material which are coated on the glass or on the surface of a particular that sheet is known as adsorbent material. Okay, so those adsorbent materials TLC are generally calcium phosphate, magnesium trisilicate, polyamide, silica gel, alumina 1:1 proportion, acetylated cellulose, ferric oxide hydrated. Those are commercially available adsorbent in a TLC, but some more coating materials used in TLC are also tabulated here in table 33.1. If adsorbent is a silica gel, then the nature is acidic. Okay, the nature of the TLC plate is acidic. Activity is it is active. Okay, separatory mechanism is a adsorption partition mechanism. And what kind of component to be separated? Acidic and neutral substance are separated. That means if you want to separate the acidic or neutral substances, then in TLC plate your adsorbent, that means the coating material, is silica gel. Similarly, if you want to separate basic and neutral component, then alumina gel is used as a coating material on the TLC plate. Okay, adsorbent, the alumina nature is basic, it is also active. Then Kilsger is a neutral. Okay, that is inactive. It is a neutral, that's why it is inactive in nature. A partition mechanism is there, and strongly hydrophilic substance. If you want to analyze strongly hydrophilic substances, then the Kilsger adsorbent material is used on a coating of the surface. It is neutral in nature. Cellulose powder is also neutral, but activity is none. Mechanism is partition. Water soluble compound. Whenever there was a water soluble compound, if you want to analyze them, if you want to separate out them, then the material used for coating is cellulose powder. Okay, remember those as a point of match the following type question, true false type, and also for MCQ type questions. Now some adsorbent do not adhere very satisfactorily to glass plate. Okay, whenever you cannot use those materials as adsorbent, like those adsorbent directly on the glass surface. Okay, so what you want to do, that to overcome this problem, some binders like gypsum, that is called calcium sulfate, or starch or hydrated silicon oxide, etc. are added to adsorbents. Okay, that means this silica gel, alumina, Kilsger, cellulose powder are not directly coated on the surface. They are not directly adhesive on the surface of the glass, and because of that reason they are mixed with these materials. binders. They are known as the binders: gypsum, starch, hydrated oxide. And because of those binders, what happen? The function of the binder is, because of the addition of that binders, your adsorbent material are coated or they are adheres on the surface of glass plates. Gypsum is probably the most widely used, that is used as MCQ purpose also. Okay, sometimes in many reference book or on many bottle of the chemicals, there are written like silica gel, capital G, alumina, capital G. So that capital G, why the G is stand there? G indicate the binder gypsum is present in this adsorbent. That is the meaning of that. Okay, that means here silica gel G, that means silica gel is mixed with gypsum. Alumina gel is mixed with gypsum. Okay, now some fluorescent indicators such as zinc silicate to coating material are also added. Okay, what happened and why the zinc silicate are added in a coating material? What is the reason behind that? Okay, the name itself suggests fluorescent indicator. That means when you add zinc silicate as a fluorescent indicator in a coating material, what happens? When it interact with the solute or the component, and when you visualize or when you study those TLC plate under the UV light, because of the fluorescent nature of zinc silicate or that particular material, what happened, you can easily visualize those spots under the UV light because of the nature of fluorescence of that particular indicator. Okay, they show up a dark spot on a green fluorescent indicator. So keep in mind this is the reason. Now second point, that is called preparation of thin layers in a plate. Okay, these are the step-by-step processes. Number one, that is the coating material which are used on TLC. Second, that is the preparation of thin layer on a plates. The large number of applicators are commercially available. Okay, those instrument or that device which are used for coating of the coating materials on the glass surface are known as applicators. Large number of applicators are commercially available which are used for coating the glass plate with different adsorbent layers of uniform thickness. Most of the method used for coating material in the form of a suspension or slurry in some liquid. That means those coating materials are in a form of a suspension or in the form of a slurry with particular solvent or liquids. Okay, the main method, that is called pouring method. Okay, in this method, simple method is there. The TLC plate is here. The measurement amount of the slurry, that means your coating material made the slurry of coating material and then put on a given size plate which is kept on a level surface. The plate is then tipped back and forth to spread the slurry uniformly over the surface. Okay, what happened here? Okay, the material that is used for coating made the slurry in particular solvent, then that slurry is applied on the glass surface and then that plate is tipped back and forth. That's why the slurry is uniformly spread over the surface. The second is the dipping method, the method developed by Pfeffer in 1962. Okay, the plates you want to prepare the coating layers on that, simply dip the glass plate into the solution, okay, into the slurry or into the suspension, and then okay, put it out and let it dry. That is the simplest way of dipping. Here the example is given to us, that is in chloroform or chloroform methanol slurry of the adsorbent. Okay, here generally chloroform or chloroform methanol mixture used as a solvent, okay, in which your coating material is added and made the slurry of that adsorbent material. It is also not much used. Spraying method. This method was first proposed by Retsema. He employs a small point sprayer for distribution of the slurry on the glass plate. You know the sprayers, okay, that some nowadays the sprayer are used for the spraying of that sanitizers. You know, in COVID-19 pandemic situation we use some sprayer, okay, that kind of some sprayer are used to spray your solution, suspension solution of adsorbent on the surface of the glass plate, but that is also not much use. The last method, that is called spreading method. Okay, in this method what happens, the slurry is placed in an applicator. This is either moved over the stationary plate or it is held stationary and the plate is pushed or pulled through. Okay, according to this line we can say that two methods are there. Number one, here in figure that is given to us. So here in first what happened, your glass plate is fixed here. Okay, but your applicator is moved in the direction of application. That is the first point. That means your applicator is movable while the TLC plate, okay, the glass surface is fixed. While here in second step what happened, that is a applicator. Okay, this is your applicator is fixed, while here that is your plate, a glass plate, the glass plate is movable. So the difference between these two is, here the plate is fixed while the applicator is movable. Here the applicator is fixed and the glass plate is movable. Okay, and by using this you can easily spread, okay, equally spread the that your coating materials on the surface. An improved TLC spreader was developed by T.Y.B.Sc, West Germany. The thickness can be adjusted from 0.0 to 2.0 mm. Okay, 0.01 to 2.0 mm. Okay, then pre-coated plates are also available. Whenever there is pre-coated plates are there, these plates are quite expensive, and the thickness of pre-coated plastic sheets usually vary from 0.2 to 0.2 mm. The third point, that is called activation of adsorbent. That is also important. When you choose your coating material, then you make the slurry or suspension and you coated that adsorbent material on the surface of the plate. Then the next step, that is how you can activate the adsorbent material. It is very easy. First of all, let it dry. Okay, so the point is, the liquid that is associated with the thin layers must be removed. That is the first step. Okay, they must be removed, and that is done by drying the thin layer plate for 30 minutes in the air, or then in an oven at 110 degrees Celsius temperature for another 30 minutes. That means when you applied the slurry or a suspension solution spray on a plastic sheet, on a glass sheet, then what happen, let it dry for 30 minutes in the air and then 30 minutes in the oven for 110 degrees Celsius temperature. That's why the solvent in which you dissolve your adsorbent, the solvent is removed, and that's why your layer becomes very dry, and it is used as a TLC plate. Okay, in order to obtain very active layers, silica gel and alumina plates can be heat at 150 degrees Celsius for about 4 hours. Remember those data as a purpose of MCQ. Purification of silica gel G layers, how you can purify them. It is also easy. Silica gel G, that means gypsum, contains iron. Iron is a main impurity which causes a considerably distortion of the chromatographs. Okay, so therefore it becomes essential to purify the adsorbent. And how it can be done? It is easy. Iron-free layers have been obtained by giving the coated and air-dry plates a preliminary development with methanol and concentrated HCl 9-1 volume by volume. That means here we prepare a methanol and concentrated HCl 9:1 ratio volume by volume solution. Then that solution is applied on that plate and then let it dry. In that manner, the iron that is present in an adsorbent layer are easily removed. The iron gas migrated with the solvent front to the upper edge. Okay, when you pass that methanol concentrated HCl over the surface of the TLC plate, they remove the iron that is present in an adsorbent. Then the plates are dried and activated at 110 degrees Celsius. Okay, generally calcium sulfate originally present as binder dissolve out during the cleaning process. Generally what happens, if you use calcium sulfate originally and you mix, if you pass the methanol concentrated HCl, calcium sulfate may be dissolved in that. So the next, that is okay, sample application, how the sample is applied on the TLC plate. Now that is a next step, sample application on a TLC plate. Okay, with the help of a micro syringe, generally used for transferring the sample solution to the thin layers for quantitative work. Keep in mind, for quantitative work, micro syringe are used, but for qualitative work, capillary tubes are used for application of a sample on a TLC plates. Okay, the development tank. The development tank used in paper chromatography is also used in TLC. Ascending chromatography is most common technique in TLC. Okay, so the development tank that is used in paper chromatography, similar tank can be used for TLC also. And ascending chromatography is most common TLC technique. Here is the diagram of that particular tank. Okay, the tank is made up of a glass, that is a lid by which the whole assembly is covered. Okay, and that is a TLC plate. The TLC plate is put it in a glass chamber, then it is covered with the lid. Okay, here 1 mm layer of the mobile phase is placed. Okay, ये जो भी टैंक हमें दिया गया है उसमें क्या करेंगे हम 1 mm और approximately 1 to 2 mm layer of the solution mobile phase is filled here. Then the whole chamber, before starting the analysis, the whole chamber is saturated with the solvent vapors. And what is the reason behind that? It is given to us here. Okay, in TLC the plate is placed in a development chamber. It is called development chamber at an angle of 45 degrees Celsius. Sorry, 45 degree. Okay, that is also important for MCQ purpose. The bottom of the chamber is covered up to nearly 1 mm by the solvent. Look at here, the data is given to us. 3 sides of the tank are lined with solvent impregnates paper, while top is covered tightly with the lid. Okay, so perfectly and the chamber is perfectly saturated with the solvent vapor. What is the reason? Because it is essential so avoid the unequal solvent evaporation loses from the developing plate, which can lead to various type of random behavior, usually resulting in a lack of reproducibility on the retardation factor. That is known as the age effect. Okay, if the chamber is not initially saturated with the solvent vapor, what happens? There is some the loss of that. The point is given to there is a loss in a developing plate. Okay, and because of that reason there is a randomness behavior in a retardation factor value, RF value, which gives age effect. Okay, next, that is called solvent system. The choice of a best developing solvent is one of the most important decision in TLC practicals. Okay, the chemical nature of the solid. If you know the chemical nature of the solid, then you can easily find out the solvent system. Okay, by using the original Stahl's triangle. Now, what is a Stahl's triangle? It is interrelating adsorbent activity, nature of the solute, nature of the solvent. 3 points are there. Okay, here. Okay, that is Stahl's diagram. Okay, here the M is a mixture, that means your sample. Then S is a adsorbent activity, E is a eluent solvent. Okay, now how it works? That means hydrophilic and lipophilic. Now look at here. If your mixture is hydrophilic in nature, okay, if mixture is hydrophilic in nature, then adsorbent must be inactive. Okay, your adsorbent must be inactive and your mobile phase must be polar. That is the meaning of Stahl's triangle. Okay, if you rotate, look at here. Okay, if you rotate the triangle, that means if M is here, that means if mixture is lipophilic in nature, then adsorbent must be active and eluent must be non-polar. That means with the help of Stahl's triangle you can easily find out the nature of the solvent or mobile phase used for the analysis. Okay, some of the solvent system are given here. The selected 1 and 2 component solvent system in order of their increasing eluting power. They are arranged according to increasing eluting power, increasing polarity. Okay, mixture of two or more solvent of different polarity often give better separation than chemically homogeneous solvent. Okay, instead of one solvent, the mixture of two or more solvent can be more useful for separation of the component. Okay, that is the table. Okay, not necessary to remember the table. The plate development. Okay, that is the next part, analysis part. The development of the plate after the practical is over. Okay, a drop of a sample placed near. Okay, how? A drop of a sample that placed near one edge of the plate. Generally the dimension of the plate are 5 into 20 or 20 to 20 centimeter, and its position is marked with a pencil. Now after the sample solvent has evaporated, the plate is placed in a closed container that is saturated with the vapor of the developing solvent, as we already discussed in the early points. Okay, that is the point here. Okay, one end of the plate is here, that is deep in a solution, a mobile phase, that is in inclined position 45 degree. Okay, those point when the mobile phase is moving in upward direction, the solute or the mixture are separated. That is the development of the plate here. Okay, detection of the component, how those component, when once they are separated on the TLC plate, how they can detect it. The most common method of a detector, that is the UV light here. Okay, put the TLC plate in a UV chamber, and because of that ultraviolet light when fall on the component, they are easily visualized, or by using some visualizing reagent also. Okay, so that is the, when colorless component are there, you can use UV light. Colored component are there, you can usually use visualizing reagent. Generally chromic acid and sulfuric acid mixture can be used in TLC. Okay, while they are not used in paper chromatography. In paper chromatography, we do not use corrosive reagent like chromic acid and sulfuric acid. That is useful for MCQ purpose. Okay, evaluation of the chromatogram. Okay, two methods are there: qualitative analysis and quantitative analysis. Qualitative analysis are same as the paper chromatography, that means measurement of the retardation factor. While in quantitative analysis, there are two methods. One is a direct method, and second is the elution method. Indirect method, elution method is known. Okay, I am going to discuss with you one by one. Direct method, that means direct visualization of those components separated on a TLC plate. That is, detector is your human eyes. With the human eyes, you can easily visualize them. That is a direct method, visual assessment of the chromatograms. Determination by measurement of spot areas. Okay, once you visualize the component that are separated on a TLC plate, then you can easily measure the area, that the measurement of the spot dimensions. The method is based on mathematical relationship between the spot area and the amount of substance present. That is a determination by measurement of spot area. Okay, quantitative TLC incorporating densitometry. So densitometry is a method where the intensity of the color of a substance is measured directly on the chromatogram. Now direct spectrophotometry on a thin layer chromatogram. So second method is a spectrophotometric method. The evaluation with the wavelength of maximum adsorption of the substance, that is known as the lambda maximum, you know that. Okay, that means with the help of spectrophotometry, the separated chromatogram zones by reading the absorption of fluorescence curve directly from TLC plate is done by chromatogram spectrophotometry introduced by Gis, Stahl and Jork. So these are the direct methods. Now in indirect method, so in indirect method we use some chemical constituents by TLC, that is recovered by quantitative elution and subsequent determination with a suitable instrument. Those methods are known as a elution technique. Now in indirect method, what happens? Once you visualize the material that is separated on the TLC plate, just remove that material from TLC plate and dissolve it in a solvent. Okay, make a solution of that material, and then that solution is undergo different kind of instrumental and chemical techniques. Let us see. The areas containing the adsorbed compound after visualization is marked, and then they scoop with the help of a vacuum cleaner. Scoop, that means they are removed from the surface of the TLC plate. Then after, the elution of the solute from the adsorbent is done by simple agitation with the solvent, followed by the removal of adsorbent by centrifugation. Okay, when you dissolve those the material which are scooped from the surface, and they undergo centrifugation, and by centrifugation what happens, the material, okay, that is also removed. The adsorbent material that is present in that spot or in that substance is removed with the help of centrifugation. Microanalysis of the resultant eluate can be performed by adopting one or more methods. These are the methods: gravimetric method, UV spectrophotometry, fluorimetry, colorimetry, flame photometry, polarography, radiometry, and colorimetry. Vapor phase chromatography. Okay, so in the assessment of the merit of any procedure, the information which we obtain from these methods are the nature of the substance, the scientific equipment available and sensitivity, the time available, and the alternative methods available, if any, and the relative accuracies. The spectrophotometric methods have been widely employed for the estimation of organic compounds after their separation by TLC. Okay, now vapor phase chromatography are used. The method has been successfully used in the analysis of citrus oil and other essential oil. It has been also used for steroid film. And combination of infrared technique and thin layer chromatography are used for the rotenons. The disadvantage of the technique, that is greater time and certain amount of substance remain unrecoverable, but the major advantage of the elution method is having a very low value of random errors compared to the direct method. So these are the advantage and disadvantage of the elution method over the direct method also. Okay, that is used only TLC is used only for small scale preparatory work. That is the only limitation of TLC, and the scope of the technique is very wide: simplicity, sharpness of the separation, high sensitivity, speed of separation, and ease of recovery of the separated compounds. Thin layer chromatography has found increasing application in all branches of chemistry. So that is all about thin layer chromatography. Okay, after watching the video, if you have any doubt in your mind, then feel free to ask me your questions in my WhatsApp group or in the comment box. Thank you for watching.